Hi. So I wanted to give everybody a little bit of guidance here talking about our assignment on population growth rates and density. Again, it should be a little clearer if you've watched our video talking about it, but I just wanted to go over the assignment in general. So you have a few different written examples here. So for each example, it says to calculate the population's growth rate and the population's density. You will also discuss if the population appears to be increasing, decreasing, or stable. Then I want you to show your work on all problems. So please remember these equations. So we're talking about population growth rate is number of births in a population minus the number of deaths in a population. So that one's pretty simple, or just a simple subtraction problem. Population density is the number of individuals in a population divided by the total area or volume of habitat. And you can set up the fraction for this one. I don't need you to actually go ahead and divide it because we're not interested in the number that results from doing that division problem. But we do want to try to reduce these fractions as much as possible in terms of the numerator and denominator that we're looking at. And then, excuse me, when we're talking about the number of individuals in a population, calculating that for population density, you want to take your starting population plus the population growth rate, which again could be a positive number, a negative number, or zero, depending on what we're looking at. So let's go through the first example together, and hopefully this will make the other examples a little bit more clear. So the first example says you are studying big blue stem grass in a prairie. Over the course of the year, about 1,000 new grass plants have started growing and approximately 500 grass plants have died. When you started your study, there were 500 grass plants. The prairie you are studying is about 100 square feet. So the first thing that we want to figure out is what is the population growth rate? And since we're showing our work on all of these problems, it's pretty easy for us to talk about all of these pieces here. So again, we're looking for the number of births and the number of deaths. So if we look back at our problem, we see that we had 1,000 new grass plants started growing. So 1,000 plants minus. So then if we're looking at how many died, we said about 500 died during our observation time. 500 plants. So again, this one is pretty simple, but again, just to show you, I'm going to bring up my calculator here. I'm guessing that most of you will have a calculator with whatever means you're completing this, either on the computer or on your phone, but I will try to get everybody a calculator app or a link to one in case you need it. And again, Google can help with very simple calculations if you want to do it that way. But we have 1,000 minus 500. So again, pretty simple. 500 is our result. So 500 plants is our growth rate. So this part here, does this mean the population is increasing, decreasing, or staying stable? So we had a growth of 500 plants. So we know now the population is increasing because it's a positive number. So increasing is our answer for that. If it were a negative number, we would say that it's decreasing. If the number was 0, we'd say that the population was staying stable. The number of births and the number of deaths are equal to one another. So then this next part asks, what is the population density? Reduce the fraction to the smallest numerator and denominator. So again, we want to figure out what our current population is. So we'll want to calculate that first. So when we started our study, so right here, this sentence, it says when you started your study, there were 500 grass plants. So we know there were 500 plants, not pants, plants at the beginning. And we're going to add our population growth rate to it, which again was a positive number. So 500 plants. And again, this one should be pretty simple math-wise, but I'm going to show you it. So let's clear our old equation here. 500 plus 500 is going to be 1,000 again, like we had earlier. There we go, it's 1,000. So now we know that the current population is about 1,000 plants. So then if we go down one line, we know that we've got about 1,000 plants. And then if we're thinking about our density, so we've got our number of individuals. The other part that we need here is the area that these individuals lived in. So if we look at our last sentence here, we said the prairie you are studying is about 100 square feet. So 100 square feet. So this is our population density, 1,000 plants per 100 square feet. But I'm betting that we can reduce this a little bit. So I'm going to put an equal sign here. So sometimes the easiest way to figure this out is to take the larger number here, 1,000, and divide it by 100 to see how many times 100 will go into that. So 1,000 divided by 100, 10 times. So we know that if we basically divide both of these sides by 100, the top part would be 10, so 10 plants. And then if we divide the bottom part by 100, again, this one should be pretty simple because we're taking 100 square feet, 100, dividing it by 100, and a number divided by itself equals 1. So 10 plants for every 1 square foot. And this is really, when we talk about its application in the field, this is basically how we want to report these things, is to say there's about 10 plants per square foot. This is something that lets someone studying this area know what the density is. So that's it. We now have it reduced as low as we could get it. If you feel after you've divided it that you could still reduce it further down, try to get it as small as you can within reason. Remember that on the numerator and denominator in your fraction, you shouldn't have any decimals. So there shouldn't be like any 10.5 out of 1 or anything like that because it's already present in a fraction. So remember that when you reduce your fractions, you want whole numbers on top and bottom. So I hope that this makes sense. I know it's a little trickier because we're pulling in some math practices. But again, if you need any assistance with this assignment, please feel free to contact me by email, by calling me at the number that I've listed in Google Classroom, or you can attend our Zoom meetings every weekday. We have those from 9:30 to 10:30 if you need any assistance. Thank you very much.